Okay, so in this video we're going to have a look at differentiation by rule. So we see here just our rules to remember when we're differentiating. If we have a constant, it becomes 0. And then our second approach is we bring down the power and multiply, and then we decrease that original power by 1. So if we look here at example 1, we have y equals 4x squared plus 2x plus 6. So I'm going to write dy dx. So all that means is I have a function y and I'm differentiating with respect to x. Reason being is just x is the only letter that we have in our function y here. So we bring down our power, which is 2. So it becomes 2 times 4 stays where it is, x stays where it is, and that 2 is 2 minus 1, plus this 2x essentially has an invisible 1 there. So we bring that down and we get 1, the 2 stays where it is, x times 1 minus 1, we're decreasing our power by 1, plus 6 is a constant, so it just becomes 0. So my next step, I'll tidy up. It'll read 2 4s are 8, x, 2 minus 1 is 1, plus 1 by 2 is 2, x, 1 minus 1 is 0, plus 0. I know anything to the power of 0 is 1. So it's equal to 8x plus 2 times 1. So dy dx is equal to 8x plus 2. Okay, so now we'll have a look at part 2. A little bit more straightforward here. So I have my function y equals 3x. So dy dx is equal to this 3x is to the power of 1. So I know if I decrease that from our previous example, 1 minus 1 gives me 0. And anything to the power of 0 is 1. So my answer is just going to be 3. That's that one done. And our last one, we have y equals a half. It's just a constant. So my derivative will be 0. So now if we come back and look at part 1, maybe a slightly quicker approach to it. We have y equals 4x squared plus 2x plus 6. dy dx will equal, bring down the 2. 4 stays where it is, x stays where it is. That 2 minus 1 just becomes 1. Plus 2, we know this x will be reduced to 0. And our constant becomes 0. And then just to tidy up at the end, 2 4s are 8x plus 2. And that's us done. And in terms of our answer, just for checking that we're right, I started out originally with a quadratic function and we differentiated it, and we now end up with a linear function. So just to show you, if we have a quadratic and we differentiate it, we'll get a linear function. If we differentiate that again, we'll get a constant. And if we go again, we'll get 0. And above a quadratic, say, would be a cubic. So if I had a look at, say, we'll take the cubic, x cubed plus 2x squared plus 3x plus 4. If I differentiate that, my x cubed, bring down that power, so we get 3x squared plus, bring down my power of 2, 2 2s are 4x plus 3. If I go and differentiate this again, bring down my power of 2, 2 3s are 6x plus 4. There's our linear function. Differentiate again, I get 6. And then differentiate 6 and I just get 0. So always that's a handy way to check your solution. If they give you a cubic and you differentiate, you'll get a quadratic. If they give you a quadratic and differentiate, you'll get a linear function. And if you have a linear function and you differentiate, you'll end up with a constant. And then, as we've seen already, a constant differentiated will just give us back 0. And that's us done.